So far, our discussions has assumed the Earth doesn't rotate. And however, we know the Earth does rotate, right? So that means for any velocity we launch from the surface must always be added up with the surface speed of the Earth's rotation, due to Earth's rotations. Okay, so that amount of the velocity components must be added in to our velocity calculations. So that is a topic for this one. So in this way, what is the Earth's rotation at any site? So let me put into this. This is the first note you need to take. I think that one page of the space should be good enough for, and okay. So if this is the equators, the first one here is the surface speed. Okay, and say if we consider a city, a place, and here, okay, so this is the first one we must know is the latitude. Okay. So the Earth's the surface speed is this. The first one we know the Earth rotate is eastbound. Okay, the Earth's rotation is eastbound, or otherwise. If you put your thumb into K, the Earth's rotation is in this sense, counterclockwise if you see from the top to the north slope, and that's counterclockwise. Okay, so this is our north slope. Okay, so this is the Earth's rotations, and this is the omega. And this number we can always find this number from appendix. Okay, so now you can see the Earth's rotation, the surface speed due to Earth's rotation, that really is regarding is how far that side away from the axis of the spinning, right? So for this city, and let me say this is the 90 degrees. So this is the distance from the surface place to the center, the rotation speed. So from here you can see the highest surface speed on Earth will be happening on the equators. Are we good? Okay, so that is the tangent. So this is the surface speed at the equators. And that number is available. That number is 1524 feet per second. This one is almost 400 meters per second, almost one loop of the track field. Okay. And now this one, what is this one? This is the distance from the site. Basically that one is, this distance is how much is radius of the Earth multiplied with so this number is 90 degrees minus L. So this one, if you look at that dimensions, that is times sine 90 degrees minus L. So basically that is R Earth times cosine L. Be good? Okay, so therefore the surface speed, let me call this is site A. With the latitude L. equal to r radius and omega times cosine L. Okay. So the first one, we know the surface speed at any site on the Earth, on the surface of the Earth, is determined by the latitude, and the maximum value always is when L equal to 0, which means the equators. If you go to the North Pole, basically the surface speed is equal to 0. Okay, so that is the first note I need to give you. And then this is the first note, and then the second note I want to give to you is the surface speed. At Earth. Is eastbound. Eastward. Let's see. Okay, they always moving to, if we take the SEZ direction, if you know the SEZ direction, S is always, the S and the E direction always go that directions. Okay? So you can easily using this kind of rotation to determine basically that surface speed is tangent to the point, and then in the same direction of the circulation, basically going that way. Okay. Okay. Now that is the component. This is the component of the velocity. We need to add it up to our calculations. So now using this slide, I'm going to do the decompositions of our speed into 3 directions in an appropriate way, and such that these components can be added up into that kind of decompositions. Okay.